Hello and welcome to the definition of the Mach number. We already heard so this is the fourth dimensionless number we are considering right now. First of all, we heard the Knudsen number to judge if we are in the continuum theory or not. We already heard the Reynolds number, it's about viscous effects, and we also heard the Struhel number, which is a dimensional flow frequency, and now we are at the Mach number. The Mach number, I already gave some hints on the Mach number when we were talking about mass conservation and compressible and incompressible fluids. And now the idea of the Mach number is to have a dimensionless number to judge if compressible effects matter or not. And the Mach number itself is the ratio between a characteristic flow velocity divided by the isentropic speed of sound. And this is how the Mach number is defined. And yeah, for certain values we can now say what is happening. So if we approach Mach 1, then the flow velocity will be equal to the speed of sound. And yeah, there are some certain regions where the Mach number and the flow has different properties, but this I would just refer you to the literature. In our context, it is now just important to define the following. We have the following result or conclusion depending on the Mach number, that we have an approximate subdivision of the flow in compressible and in an incompressible flow. So usually it is said that we can model a fluid, or we should model a fluid compressible if the Mach number is above 0.3, and we should model a fluid incompressible if the Mach number is smaller than 0.3. This is not a hard limit, and certainly there are some flow states where we should also compute the fluid compressible for very low Mach numbers. For instance, if we have some feedback of the acoustics on the flow. But this is a very specific topic which will be addressed in the examples of air acoustic itself in the course we are giving at TU Graz. So if you're very interested in how this actually is happening in air acoustics, and where we have to compute also a kind of an incompressible flow regime, compressible because of air acoustic feedback, I would like to refer you to the course at the TU Graz, or you just simply can write me an email. I think you find some email address of mine in the following web page. And yeah, that's basically it from the Mach number. So just a small recap: the Mach number can be used to define if we should model a fluid compressible or can model it incompressible. In the incompressible state, some equations are a little bit simpler. The simulations will probably take a little bit shorter than when modeling it compressible. Thank you. That was the Mach number.